Howdy. I did this part in 2 sections. I did not cover this in 1 section. Anyhow, it will be a good review for all of you. Addition of phosphorus ylides. What is phosphorus ylides? I put the general structure here. This can resonate, and you can have the resonance structure of it. You can write the phosphorus ylide either this way or that way. We can also call them as Wittig reagents. They are pretty easy to pronounce. In these, the R groups or hydrogens or alkyl groups or aryl groups or combination of any two. How to make them? We had to make them from alkyl halides. For example, if you want to make this Wittig reagent, examine the carbon and the 2 R groups on it. So you must select an alkyl halide that contains that group on the alpha carbon. Look at it here. I selected an alkyl halide which contains those 2 groups and a good leaving group, iodine, and a hydrogen. If you treat that alkyl halide with a triphenyl phosphine, the triphenyl phosphine is a nucleophile. It reacts with it by a Sun2 reaction and form this product, I minus left. And then this drops the proton and flip the bond here. It is pretty simple. I'll do some examples on it. Look at this one. This is nothing but this. The one thing I did not mention it, I'll go back and do that. In this one, this is a phosphorus. This group is a phenyl group. You know what is a phenyl group is? If you don't remember it, this is the phenyl group. There are 3 of them bonded to the phosphorus. So this is this one. So this contains actually a hydrogen and a methyl group on the carbon. So I had to select an alkyl halide, which contains that hydrogen and the methyl group on its alpha carbon. So if you make it as actually halide, this requires another hydrogen. You treat that with the triphenyl phosphine. And you know, as I showed it, this reaction produces this intermediate, the hydrogen and the methyl. The next it drops the proton and becomes this one. So you simply treat an alkyl halide with a triphenyl phosphine. If you want to synthesize this one, this is nothing but this one, PH3P, and double bond, you have a C, ethyl and methyl group. So you have to select an alkyl halide that contains that group. So you say a methyl and ethyl on the alpha carbon. I will use the iodine because it is a good leaving group. You can use bromine or chlorine there. So if you see, the rest of it is the old story. It goes on, flip it, and then you have this product. Actually, this is an intermediate, and then this drops the proton and becomes this one. The phosphorus ylides or the Wittig reagents add to the carbonyl group by the mechanism below. You can use it in this form, or you can use it in ionic form. It is pretty easy. Convert this double bond into a single. Then this will be a negative. This will be positive. This is a resonance structure of that one. So look at the carbon. It is a nucleophilic carbon. It adds to the carbonyl carbon, and this flips. And then you have lone pairs. It actually bonds to this one. So the product in this case is this, a 4-membered ring. Remember, the phosphorus is one of the ring members. Many of you write it PH3P and then make the ring here. It is wrong. The phenyl group is present on the phosphorus. The 4-membered ring is not stable. It has angle strain. It may also has a torsional strain. We learned that in chapter 4. The next thing which is going to happen, this breaks and goes there, and you get actually an alkene. The triphenylphosphine is oxidized. You need not write this one. So the product is an alkene. So the Wittig reaction produces a product alkene. So examine this mechanism. What happened to the carbonyl group? The carbonyl oxygen is here. It is lost in the product. It is not there. What happened to the triphenylphosphine pod in the Wittig reagent? It is here. It is here. It is lost. It is not in the final product. So basically, in this reaction, the carbonyl group loses its oxygen. The Wittig reagent loses its triphenylphosphine, and the leftover parts join together, say R and R prime. It is an alkene. If you remember this, you can write the product of any Wittig reaction. In all Wittig reaction, we are going to have a Wittig reagent and an aldehyde or a ketone. So basically, you take it, and put the pieces together. So you get this alkene. In this case, you take this, and here it is given in the ionic form. If you're not comfortable, make it as a double bond and take it. So now you have the double bond is there. This has a C and a hydrogen and a CH3. So examine these products. These are all alkenes. In alkene, one part of it, one side of the double bond is coming from aldehyde or a ketone. You see, one side. In this case, it comes from the ketone. Here it comes from the aldehyde. The other side comes from the Wittig reagent. If you keep that in mind, you can find out the precursor of any alkene that is prepared by the Wittig reaction. Look at here. This one is prepared by a Wittig reaction. What is the precursors to it? Just break it. Just imagine breaking it. You get two pieces there. One, just keep the double bond. And here, put an oxygen to one and triphenylphosphine to another. So if you have that ketone and that Wittig reagent, they will react and give you the product. You can also do the other way. You have the same pieces, and you have the same pieces, one, and make this as a Wittig reagent. Remember, the phosphorus is bonded to the double bond. So if you use this ketone and this Wittig reagent, they will also produce this reaction. It's pretty simple to figure out. We can do some synthesis. We can synthesize an alkene, big alkene, by using the Wittig reaction. Here is one of them. We have to convert 2-butanol into 3,4-dimethyl octa 3-ene. What is 2-butanol? There's 1, 2, 3, 4. And we have to convert this into octene 2, 4, 6, 8. So on the third carbon, you have a double bond and a methyl and methyl, 1, 2, 3, 4, 5, 6, 7, 8. So we have to use the Wittig reaction. Just to look at the precursors for this. If you break it in imagination, you're not breaking it actually. So you need this and this side. So you can have one as a ketone, which is given here. The other one is actually Wittig reagent. If you have these two, you can take this out and make them. But it is pretty simple. But what is the problem? B says, if you are using any Wittig reagent, of course we used a Wittig reagent. You need to prepare it from an alkyl halide. That is a piece of cake to you, because this is a Wittig reagent, contains a methyl group and butyl group on the carbon. So you are going to select an alkyl halide that contains a hydrogen and iodine, and those two groups, methyl and butyl group, and then treat it with the triphenylphosphine. And then you know the rest of it. It goes there, this pH 3P, positive, and this has a hydrogen, and you have a methyl group and butyl group. And the next step, it drops the proton and becomes this. So it is a pretty simple.